Round Top is an extinct volcano east of Oakland, California, in the Diablo Range of low coastal mountains that lies along the eastern margin of the San Francisco Bay lowland. Round Top is one in a cluster of four volcanoes formed 10 million years ago because of the opening of the San Andreas Fault southwest of here near Santa Cruz. Today, the San Andreas Fault extends 1,300 kilometers from the Gulf of California north to Cape Mendocino. Land to the west of the fault slides to the northwest about 35 millimeters each year relative to the rest of North America. Beyond the northern end of the fault, the Pacific Ocean floor slides eastward and down below the western edge of the North American continent. The descending oceanic plate blocks the northerly motion on the west side of the fault, which increases the pressure and heating of the descending material, and in turn produces magma that rises to the surface in volcanic action. The San Andreas Fault first opened in the south 29 million years ago, and by 10 million years ago it had extended north past Monterey Bay, giving birth to Round Top and her sister volcanoes close to shore and just to the northeast in the Berkeley Hills. Walking east to the north flank of Round Top, we can see most of the park lying to the north. Look closely at the parallel lines crossing the low, grassy hills. These are the traces of sedimentary rock layers that have been tilted from horizontal to vertical with an eastward rotation. The layers become older from right to left, from east to west. A fault runs along the wooded valley to the left, one of many local faults that runs parallel to the Hayward Fault, which defines the eastern margin of the San Francisco Bay lowland. Think of the rock layers whose edges we can see as pages in the books on Earth's history that nature has written for itself, and left stacked in a neat pile as it went on to more recent work. We call each of these stony volumes a geological formation. 14 to 16 million years ago, this region was a marine basin a mile deep. That basin was then lifted above sea level and a range of coastal mountains raised where San Francisco Bay and the Golden Gate lie today. Between 10 and 12 million years ago, streams running east carried gravel, sand, and mud eroded from those coastal mountains and spread them out in a plain bordering an inland sea whose shoreline was where the towns of Lafayette and Orinda are today. Then, between 9 and 10 million years ago, Round Top and her sister volcanoes erupted periodically, spreading layers of basalt lava over the countryside. Between eruptions, sediments would build up as before by the action of streams and the settling of lake bottoms. Over the last 5 million years, our stack of geological formations has been fractured and toppled by the force of colliding earth plates. These formations have been shifted laterally and vertically along fault lines between them. All this means that the Round Top volcano is now lying on its side, its roots pointing west and its crown pointing east. We will follow the path of Round Top's lava from its interior eastward through its vent, and then to the northwest along the ridges we can see on the right. Our starting point is right behind us. A cut made into the side of Round Top to make level ground for a municipal water tank has exposed one of the volcano's feeder tubes. We are looking at a moment from 10 million years ago, locked into stone. This is a basalt dike, once a column of lava flowing up into a volcanic crater. We return to the trail, following it east toward the site of the ancient vent. From the base of Round Top, we can see all of its mass clearly. Our trail will now wind around toward the grassy ridge seen in the upper left. Halfway there, we should find the crater. This pit was once a quarry from which a large quantity of basalt was removed. That basalt once filled the interior of the Round Top volcanic crater. Our vantage point is at the lip of that ancient crater, which is now tipped vertically. Notice the vertical layers of compacted ash which were originally laid down horizontally. This isolated block of cracked basalt looks like the helmeted head of an ancient bearded warrior. For a time between 9 and 10 million years ago, lava rose into the tipped crater from the left, filling it with basalt and eventually capping itself with the mound of ash and lava seen at the right. Let's look more closely at the face of the crater. Nature is not the only artist of works in stone here. People enjoy leaving their marks as well. One can imagine prehistoric people seeing this mound of crumbling lava as a gigantic ash heap left after mythical deities had used earth-forming furnaces here. Looking off into the east, we see Mount Diablo, which gave its name to the range of coastal mountains just east of San Francisco Bay. Mount Diablo was born about 2 million years ago when a mass of 90 to 190 million-year-old rocks, which had been distorted by compression and heating, burst through the softer sedimentary layers left behind by the retreat of the inland sea to Southern California. Mount Diablo was never a volcano, and it continues to grow 3 to 5 millimeters each year. From a grassy clearing uphill from the quarry pit on Round Top's eastern flank, we can scan the Diablo Range from the northwest right around to the southeast. The trees covering Round Top's southern slopes are both introduced species, Australian eucalyptus and Monterey pines. The eucalyptus and pines dissipate the wind, capture moisture, and shelter plants and animals below their branches. Perhaps now, when we look at the quarried slopes of these northwest trending ridges, we can more easily visualize the vertically tipped stack of layered, solidified lava flows. Let's go back past the quarry pit and see what we find along the trail to the northwest. This road cut exposes river gravels, sands, and mudstones of the Orinda Formation. Here, we walk over massive basalt. We arrive at a junction between Orinda and Moraga formations. This small grayish cliff is a cross-section of a vertical layer of Orinda Formation mudstones. To the left of the distant marker post, we see the towering remains of a vertical layer of basalt which has been partially excavated. At the next quarry pit, we see a nearly vertical layer of lava that formed into pillars because of shrinkage as it cooled and solidified. On the left is a layer of basalt that was still hot when volcanic ash fell on it and was baked red. These layers are tilted up toward the east to the right. Thin lines in the compacted ash show it fell into water. The ash came from Round Top, which you can just see in the right distance. The basalt flow on the right contained trapped gases which escaped, producing the bubbly texture. The flow on the left was of pure basalt. These fallen blocks are made of a reddish-brown lava which cooled and hardened while it was still moving, so it fragmented. Here, a layer of ash is sandwiched between two lava flows, the older one to the right. The ash was baked red by both flows. That younger flow was probably 30 to 50 meters thick, which we may be able to visualize by looking at the space scalloped out of the hillside by the quarrying for basalt. Cinders that flew out of Round Top clumped together into reddish stones and larger deposits wherever they landed. Our trail ends about 1 mile northwest from Round Top. Before us is the Siesta Valley. This valley formed by the folding of Earth's crust as if it were a postcard held along opposite edges between the fingers of nature's titanic hand and squeezed so it flexed down into its palm. This is a syncline, a bowl-shaped distortion of a sequence of rock layers. We can visualize the rock layers we observed in Sibley Park to plunge vertically and nearly vertically into the earth, curve up to horizontal further east beneath Siesta Valley, and then continue curving up to emerge at steep angles beyond Siesta Valley. Here we can see the folding of the continental margin because of its collision with the oceanic plates. Our story is done. It is time to go home.